Hi, I'm Val Huber. Welcome to this demo of Automated Business Logic for ZK. What we're going to do is look at a small order entry application focusing on the business logic as we compute the balance and check the credit limit. So here's our sample application. It's got customers, orders have line items, and we want to do transactions against these line items and the orders. For example, change the quantity to 1. Notice the change in the balance as I click that. Or we might want to reselect the product. There again, it's changed. Or we might want to test our constraints by trying to buy lots of these. And we get told, as appropriately, whether that's a balance exceeded constraint. Now, let's have a look at defining that shared business logic with automated business logic in such a way that it's shared for all controllers and even message-based transactions as opposed to put in a particular controller. To build a ZK application, you proceed as usual. In this case, we're using Hibernate. So we build the beans here, the domain objects. You build your controller here. As we noted earlier, you would not put business logic inside the controller. And where automated business logic comes in is you define logic classes that correspond to your domain classes. These enforce the specifications that you provide like this. So let's now take a look at exactly what logic we're trying to enforce. Let's consider the use case. We looked at many in that application, but let's look in particular about how on changing an order, we want to check the credit limit to make sure it's within check the balance to make sure it's within the credit limit. We might formally define that on a spec or even a cocktail napkin as follows, talking about a constraint where the balance is less than the credit limit. And in automated business logic, you enter that almost exactly as you would have in the spec. So what is this? This is the business logic class we just mentioned. These annotations identify logic methods. In this case, the type of method is a constraint. The condition of the constraint is this, and this is the message that we saw in the dialog box. Now, so often happens, there's a stepwise definition of terms to uncover the logic. So having identified that the balance must be less than the credit limit, we might now ask, what is the balance? And we might answer, for example, a business user might answer that the balance is the sum of the unpaid order totals. How do we enter that? Again, pretty much the same way. Here is the definition of that rule. Again, it's in an annotation, so that's what the business logic engine looks at in order to do the enforcement. This says, from the perspective of the customer, go get my related purchase orders, total the amount total, including only those purchase orders where paid is false. You can look on our homepage. This is not a SQL aggregate query. There's very sophisticated optimizations applied to that. We next look and continue our stepwise definition of terms, trying to understand what is an order total. We might hear from the business user that that's the sum of the line items amount. So we enter that rule on the purchase order logic, shown here, just as pretty much we said it in the spec. Again, we ask, okay, what's the line items amount? Well, that's the price times the quantity, where the price is obtained from the corresponding part. That's literally all you do to define the logic, not only that solved our credit limit check, but all the other transactions I did are automated just from these specifications. Let's now take a quick look at how that business logic engine works. From the perspective of the developer, as you saw, we defined the model with Hibernate, the view by defining ZOL files, and the controller in Java. When it starts to run, the ZK framework invokes your controller, and you code that to invoke Hibernate with the existing API. The business logic engine, just a jar file, plugs into Hibernate events and looks for these rules that we defined and enforces your business logic for all changes. That is, it's not restricted to a particular use case. The system is looking to make sure that this logic is reused over any transaction that touches that data. This has important implications for your business. First of all, agility. We built this application two ways. We built it with automated business logic, and we built it with the traditional approach. In the traditional approach, there was literally 500 lines of code that we replaced with the 5 rules that you saw. That's saving about half of your project. Extensibility is also a part of the story because while this transaction was very simple, uh, the system's design enables you to support Java or Groovy, so you can provide extensibility addressing complex transactions like the bill of materials. You can use your IDE's debuggers, logging, you can use code editors. All this is built into the product. And finally, in addition to the story is bigger than agility, it's really about total cost of ownership. The rules that we just saw can be spun off into reports provided to business users who can engage with IT to help reduce requirements risk. As we noted during the demonstration, these rules are automatically reused over every transaction, giving a measure of compliance that's really not possible with manual code. Automatic ordering means that these rules are specified in any order you wish. The system uses introspection and bytecode analysis to determine the dependencies between the rules and therefore a proper order of execution, so that during maintenance, you simply change or add or delete the rules and the system reorders the logic, replacing the vast majority of work done in maintenance to understand the dependence of existing code. And finally, the system provides enterprise-class performance optimizations, which you can read about on our website. So have a look at our website. There's much more detail there. You can also download the product and have a look at it, and we'd love to hear from you. Thanks very much.